Hi, I'm Isabella, member of EPOS Projetos Aeroespaciais, and I'm going to show you the Black Canary project, which is a 3-unit CubeSat for meteorological purpose. Now, let's embark on a space journey to better understand Black Canary. The mission of our CubeSat is to take measurements and tests on atmospheric pollution in order to analyze the impact of pollutants on increasing COVID-19 cases. This is important for two reasons. The first is to show how pollution can harm people's lives, especially in times of crisis, such as a global pandemic. And the second is to make a CubeSat that is viable to be used by institutes or companies that need meteorological data and measurements, taking advantage of the favorable economic moment in the aerospace sector, called New Space. The orbit chosen for our CubeSat was the low Earth orbit (LEO), which is an orbit in which the satellites are below 2,000 kilometers. CubeSat being the low Earth orbit will find atmospheric gases in the thermosphere, approximately 80 to 500 kilometers above the surface, or exosphere, approximately 500 kilometers above, depending on the length of the orbit. According to Kizernik 2004, the temperature estimated in LEO orbit can range from -80 degrees Celsius eclipse and 53 degrees Celsius insolation. The EPS is composed of an energy source, an energy storage system, and an electrical power management and control system. For this project, a CubeSat 3U solar panel will be used. The cells will be in a parallel electrical configuration. This is advantageous because if one cell fails, the other cells can still operate and guarantee mission's continuity. The chosen battery is the CubeSat 40 watts per hour CubeSat battery. The technology high energy density allows greater amounts of energy to be stored in a small volume. The battery also has a long life cycle, which is important to extend the mission's maximum duration. It's important to know that the main advantage of this technology is an extremely high charging efficiency, around 97%. It's also suitable for cold environments, such as the background temperature of cold space, especially during the eclipse phase, where no heating effect by radiation occurs. As a part of the TT&C system, the ground station (GS) is responsible for receiving data from the satellite, analyzing, diagnosing it, and sending commands to fulfill the satellite's needs. Our planned station will be located at Lorena, São Paulo. We decided to use a pair of WAG antennas controlled by a directional engine which will be able to correct the antenna's pointing and polarization. The antenna's mast will be adjustable to fulfill the system's needs and will be connected with the directional engine at its top. This design will have two signal splitters, which will distribute the signal through the feeders of both antennas. So, according to this design, the received signal from the satellite will be conducted along the main signal cable and will pass through a signal amplifier, which will use sustain it until it gets the transceiver radio. The radio will pass the signal to the modern responsible demulator and send it to the station computer, which will diagnose the data and guide it way back to the predetermined commands. The OBD used in this project is the OpenOBC. This onboard computer was chosen because its processor is better for our project than other models, which stands greater temperature variations, which happens in the chosen orbit (LEO), has high performance and reliability and low cost benefit for being manufactured here in Brazil. Thus, the Operation OBC system is the one that best fits our project and mission. The ADCS model adopted, for simplicity, has three linearly independent reaction wheels mounted in the directions of X, Y, and Z axis of the CubeSat. The P-motor angular velocity controller was highlighted, as well the DC motor model that computes the torques and angular moments of the reaction wheels. The financial analysis was divided by subsystems to have more accurate values. And that was the trip with the Black Canary project. Thanks for your attention and see you on the next trip.